Hey everyone, and welcome back to The Explainer. Today, we are diving headfirst into something truly mind-bending. What happens when you give the powerful AI minds we know, like ChatGPT, an actual physical body to interact with the world?
So that's the big question we're tackling today, right? What happens when you take an AI that's basically read the entire internet and give it hands and eyes and the ability to actually move things around in your room? Well, this isn't science fiction anymore. Researchers are figuring this out as we speak, and the answers are pretty incredible.
But before we get to the cool stuff, we have to understand the main hurdle here, what you could call the AI-robot gap. You see, for years, AI and robotics have been on two totally separate paths. And, well, getting them to work together is a lot harder than it sounds.
I mean, think about it like this. A normal large language model, it's basically a brilliant brain floating in a jar. It can write a sonnet, it can find a bug in your code, it can explain quantum physics, but it has absolutely zero real-world experience. It doesn't know the feeling of picking up an apple or the weight of a book. It's all just information, completely disconnected from physical reality.
And that's the core of the challenge. On one side, you have the LLM with its amazing grasp of language and common-sense logic. On the other, you have a robot that needs to actually see the world with cameras and sensors and then physically do things. The whole goal here is to merge these two worlds. Give that powerful brain a body and give that body a really, really smart brain.
So how in the world do you bridge a gap that big? Well, the solution is to give the AI senses. We're moving past AI that just deals with text and building new ones that can actually see and understand the world around them. And that's where the multimodal solution comes in.
A multimodal LLM is the absolute key to this whole thing. It's an AI that doesn't just get words. It can look at a picture you show it, it can watch a video, and it can process your text command all at the same time. This is so crucial, because for a robot to do something in the world, it first has to see the world. This technology is literally giving the brain its eyes. Now, this is where it gets really cool. Because when you finally connect that seeing, thinking, multimodal brain to a robot's body, you suddenly unlock a whole new world of abilities. The research we're looking at today actually calls them 3 new robotic superpowers.
And those 3 superpowers? They are planning, manipulation, and reasoning. Now, together, these 3 things represent a massive leap forward for what robots can do. We're talking about moving from a machine that does one thing over and over to something way more adaptable and intelligent. Let's break them down.
First up, we have planning. So, imagine you say something simple, like clean the table. For us, that's a no-brainer. But a normal robot would need every single little step programmed in. With an LLM for a brain, though, the robot can just use its common sense to figure it out. It knows it should probably pick up the plates first, then get the silverware, and then wipe the table down. It just creates a logical plan from a simple human sentence.
Next, there's manipulation. And this is way more than just grabbing stuff. It's about interacting with things smartly. The LLM gives it that common sense context it's been missing. It knows that an egg is fragile and needs a delicate touch, but a heavy book needs a firm grip. It understands you should place a glass on a table gently, not drop it from 2 feet up. This is the how of doing things right, all guided by a deep knowledge of the world.
And finally, there's reasoning. This might be the biggest game changer of all. What happens if you say something vague like, "Hey, it's getting kind of dark in here"? A normal robot would have no idea what to do. But a robot with an LLM brain can reason. It understands the intent behind your words. It figures you probably wanted to close the blinds or maybe turn on a lamp. That ability to read between the lines is what separates a tool from a true assistant.
Okay, so this all sounds amazing on paper, right? But the real question is, does it actually work in the real world? Well, to find out, researchers put this exact idea to the test, a big one. So here's what they did. They took GPT-4V, that's a super powerful AI that gets both text and images, and they hooked it up to a real-life robot arm. They basically made it the robot's brain. Then they threw a whole bunch of tasks at it, everything from picking up toys in a mock kitchen to rearranging blocks on a table. The goal was simple. Could the AI figure out what to do just by looking at the scene and reading a command?
And the results? They were honestly pretty amazing.
The researchers used something called a matching score, which is basically just a grade for how well the AI's plan matched the perfect, ideal solution. And look at this. Across all these different tasks, the scores were consistently high. For a complex kitchen setup, it scored an 8.5, and for a simple block stacking task, it got a perfect 10 out of 10.
So what was the final grade? Across every single one of these tests, GPT-4V's plans hit the mark with an average accuracy of 8.7 out of 10. That is a stunningly high score. It proves this isn't just a neat idea. It's a genuinely effective way to build much, much smarter robots.
And you don't have to take my word for it. The researchers' own conclusion says it all. They said, the experiment underscores the potent image understanding and logical reasoning capacities of multimodal LLMs. In other words, this works. This is a solid foundation for the future.
But as promising as all of this is, let's not get ahead of ourselves. The work is far from done. This is the absolute cutting edge, and there are still some really big challenges to solve on the path to truly smart, embodied AI.
We have to be realistic here. We're seeing the very first wobbly baby steps of this technology. Getting from what we just saw to a robot that can reliably help out in a hospital or around your house, well, that's going to take a lot more work.
The paper was actually super clear about the current limitations. For one, these AIs still kind of struggle to understand 3D space from a 2D camera image, so they might misjudge depth and mess up a grab. They also need really long, carefully written prompts to work their best, and they're often stuck with a preset list of actions they can perform. On top of that, using these big closed-source models can cause a lag, which is a big no-no for robots that need to react in real time.
But the motivation to fix these problems? It's huge, because if we can crack these nuts, the possibilities are just transformative. We're talking about robots that can help with delicate harvesting in agriculture, assist surgeons in advanced healthcare, and maybe even one day be controlled by brain-computer interfaces, linking our thoughts directly to robotic action.
Which brings us right back to where we started. We've taken an AI that has learned from pretty much all of human knowledge, and we've given it a body to act on that knowledge. It's a massive step, and it leaves us with one final, huge question to chew on. If our robots can now learn from everything we've ever created, what will they learn to do next? Thanks for watching.